Hi everybody, welcome back to class. In this video, we're going to be going over the different types of measurements again for length, mass, and volume in preparation for your quiz. In this first problem here, what I want you to do is read this meter stick, and I want you to try to read it to the best of your ability and to get the right answer. In this case, the answer comes out to be either 1.27, 1.28, or 1.29 centimeters. The reason it is 1.27, 1.28, 1.29 is because we know that there needs to be a 1. It's for sure there. We know that the measurement goes past the 0.2 mark. So it goes past 1 centimeter, it goes past 0.2 centimeters, and now we have to guesstimate. But when we guesstimate and we look here, it looks to be pretty well over halfway. And because it's over halfway, we can't have 1.25 or 1.26 because of how close that is to the halfway point. For this answer, we're looking at 1.27, 1.28, and 1.29 because it's close to the 0.3 mark. Again, we know that it's 0.2, but it's not quite to the 0.3. Because of that, the measurement, that last decimal place there, is your guesstimation mark, and we're guessing that it's closer to the 0.3 than halfway or to the 0.2. Let's move on to the next one here. I want you to try to read this meter stick to the best of your ability to come up with the correct answer. In this case, the answer could be 5.09, 5.10, or 5.11 centimeters. The most common answer is probably going to be 5.10 centimeters because it looks like this mark is dead on that line. When it's dead on that line and it's dead on that 0.1, that's where you have to have that 0 afterwards. You got to have that 0 because it's showing that it's right on here. Somebody could have said it's just slightly before that, which is why it's 5.09 is correct. Or you could have said it's just slightly past the mark, and that's why we have 5.11 centimeters. Moving on now to mass, and remember with mass, we're measuring with the triple beam balance. Remembering with mass and the triple beam balance, we're measuring with the unit grams now. With our meter sticks, we're looking at centimeters. With the triple beam balances, we're looking at grams, the little g. So what would be the mass shown on this triple beam balance? The most common answer probably is going to come out to be 112.10 grams. And you get that by adding up all the different beams. So 100 grams plus 10 grams plus 2.1, and it looks like it's dead on that. So 2.10 grams. Add them all together, you get 112.10 grams. Now you could have said that it's slightly past the line, so that's how you get 2.11 grams. You could have said that this mark here is slightly before, so you could say 2.09 grams to get 112.09. But it's for sure 100, and it's for sure 10, and it's for sure 2. So that's why it stays 112. The only thing it's changing is our guesstimation here, our little tiny guess of where it would be. Again, the most common answer is probably going to be 112.10 because it looks to be dead on that line. Let's move on to the next one here. I want you to try to read this triple beam balance to the best of your ability. The answer for this comes out to be 183.80 would be the most common answer. 183.80 grams because we have 100 plus 80 plus 3 is 183. And then we're for sure have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8. So almost all of these here will have the 0.8 in them. To me, it looks like that is right on the line. And if it's right on the line, then it's going to have a 0 after it, showing it's right on the line. But somebody could have said it's slightly past a line, so that's why it's 0.81. Or it's slightly before the line, which is why it's 0.79. But this is probably going to be the most common answer. We're moving into volume now. And with this, you should understand how to work with volume by now, with volume of a cube, just because you've worked with it for so long, not just in science class, but in math class. And I'm just showing you this example so you know how to work through it. Length times width times height. For this, you're going to take 45 times 25 times 15. Make sure you multiply. Don't add them together. Multiply them all together. You get 16,875. The next part is make sure you have the correct unit, which is going to be centimeters cubed. Centimeters cubed, and it's at 3 because centimeters times centimeters times centimeters. Now we're on to reading the graduated cylinders. So let's look at graduated cylinder A first. Remember, the first thing we got to do is figure out how much does each graduated cylinder go up by? How much are the tick marks going up by? So in this case, let's just start at 10, and let's just always guess 1, just to see what happens. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Yeah, it makes sense to go up by 1s, so we're good there. We're going to say it goes up by 1s. And remember, if they go up by 1, they're going to have 1 decimal place in the answer. If a graduated cylinder goes up by 1s, it's going to have 1 decimal in the answer. So let's look at the measurement right here. What would be the volume of the liquid at that line? Well, the answer comes out to be 17.0 milliliters because it looks to be right on that line. Could you have said 16.9, saying it's below it? Yes, and it still would have been correct because of that guesstimation in there. You could have said, I mean, it doesn't look like it, but could have said the line is somewhat over top of it, which would have been 17.1, but it doesn't look like it there. The best guesstimation would be 17.0 because it looks to be right on that graduation there. Let's look at B. What would be the volume of B right there where the liquid is at? The correct answer comes out to be 25.0 because again, everything goes up by 1s, we need to have 1 decimal place in the answer. Because it's dead on that line, because it's right on that 25, we're going to say 0.0. The last one here, C, comes out to be actually 21.5. And this is one I wanted you to see as an example. It comes out to be 21.5 because we have at that line 21 and at that line 22. Well, you ask yourself, what comes between 21 and 22? Well, and because this line, this liquid here, looks to be halfway in between, we say 21.5 is in between 21 and 22. Because everything goes up by 1, we can have 1 decimal place. Because it fell in between, it comes out to be 21.5. So the last one we have here is volume by water displacement. We're looking at volume by water displacement. And remember, water displacement is when we put an object in a graduated cylinder full of water and it pushes the water up. So to calculate water displacement, we need 2 things, the final volume and the initial volume. The initial volume, VI, is going to be when there's no object in the graduated cylinder. It's just a liquid. So in this case, it's the empty. And we're going to read it right here at this line. Right there at that line comes out to be 13.0 milliliters. Everything goes up by 1, so everything needs 1 decimal place in the answer. So we want to find the volume of the button. Let's go for the volume of the button, VF. So this is our VF. This is not the volume of the button, this is VF. This is after we've added the button to it. And the volume there is 15.0 milliliters because it's right on the line. Remember, that's final volume. That is not the volume of the button. To find VO, or the object, in this case the object is the button, we're now going to take VF minus VI. So VF was 15, VI was 13. 15 minus 13 comes out to be VO equals 2.0 milliliters. Or you could have said 2.0 cubic centimeters because it is a solid in there. Either one of them would be correct. Hopefully this video and this homework helps you out a little bit before your quiz on Monday. Everybody have a wonderful day and have a wonderful weekend.